And the remote control has completely abandoned me now. So as far as analysis on this, we are using a capacitance bridge sensor. However, when we were using this design, which is a fairly normal design, we couldn't get it to null across the middle. It was very odd. So, so what we did instead was we flipped the capacitor and the resistors, and we could get it to null. The problem that we were having with this, however, was that we were getting, there we go, a phase lag of roughly 6 milliseconds. And this was using an industrial capacitor as one side, and then our electrolytic capacitor on the other side. So I thought maybe it was just had something to do with the types of capacitors that we were using, and I introduced a second unknown capacitor, or the other side being the aluminum rod in the solution, and the phase lag went away. So some advantages that we have here with our sensor is that, first off, it's fairly temperature resistant, in that if the temperature goes down, then the solubility of the sodium bicarbonate in the solution goes down. However, this affects the whole entire system of capacitors instead of just one. And the capacitors are actually going to be in like cardinal directions, so we can get it on a whole plane of motion. So it is temperature resistant in that if the solubility does change, it changes across the capacitors. So we end up with it still nulls across the middle. We're just concerned more about changes in capacitance rather than the actual physical capacitance itself. Yeah, as I mentioned, this has a whole plane of measurement, which is great for our experiment in that we want to measure undulations or modulations rather in the change of the apparatus. So these, if say the building is sinking, then it will move at usually a DC sort of way. If we have an earthquake or something, that'll move at an AC, it'll go back and forth. And we want to know, especially since we're moving the attractor plate in and out at 100
seconds.
Once every 100 seconds. We want to make sure that we're not also experiencing that somewhere else in the system. All the other changes we can get out, subtract out of our data, but we want to make sure that any change in any modulation that we're seeing is in fact from the attractor plate. It'll measure subtle changes over a long period of time. It'll measure shocks in the system, but it won't be affected by them for long periods of time. So it will measure earthquakes, it'll measure very large trucks coming through, it'll measure things like that, but it will reset itself fairly easily, so we can find those bits of data and get rid of them. And this can reach the sensitivity that is needed. We can get down to microradians with the tilt sensor. We need nanoradians in twist, and so so it works out that the microradians in tilt change will be able to measure the nanoradians. Some disadvantages. There is evaporation in this water, and stuff in water. Inherently, the evaporation will be slowed down by the sodium bicarbonate that's in the solution. Again, the great thing about the way that it's set up is evaporation generally doesn't happen on one side and not the other. It happens across the field. So again, this will be countered by changing or measuring the change in capacitance rather than the actual physical capacitance of each capacitor. We've got stuff in water. Corrosion happens when you've got stuff in water. The aluminum is not such a big deal. It's got that oxide layer that is going to work against corrosion and for the dielectrics. So corrosion is not a big problem with the actual rods immersed in the water. However, as far as a ground, we need to use something like gold or something like that that won't corrode in sodium bicarbonate in water. Thermal changes, as I mentioned before, can cause a change in solute, but again, since we're actually just measuring the change between the capacitors, that should be an okay thing. There is a potential phase lag that is introduced, as I mentioned before. That was canceled out when I used the aluminum rods in the solution instead of an industrial capacitor. It could become an issue though if there are different capacitances across the capacitors. So that's another thing that we need to work on and try to eliminate, make sure that's not going to be an issue. And the bridge circuit at this time, because the capacitance is so big, the bridge circuit, amusingly this was not, I did not draw this up here, it was already here, but the bridge circuit has actually shown to be less sensitive than just measuring the change in voltage by pulling the aluminum rods in and out of the solution. So that's kind of weird, and we want to find perhaps another way to measure that can also act as a noise reduction, so we don't get a lot of electrical noise. Here are